Hey guys, just want to make a quick video for you real quick about the math for the VO2 Max for the metabolism lab this week. So real quick, as far as what is a VO2 Max? So in this lab, you're going to calculate a VO2 Max, and you're going to calculate your resting metabolic rate. Okay, so I can't remember if you do resting or basal. Anyway, so kind of what the difference between those. I think of it this way: when you go to the grocery store, the little price stickers have the total cost of an item, and they have the price per ounce. The price per ounce lets you compare different brands of a similar product just to see what's going to be a better deal. And then the total cost, of course, is the total cost. So your VO2 max is kind of like your price per ounce. It's in terms of liters of oxygen per kilogram per minute versus your resting metabolic rate. That's just going to give you, I think it's just it should be liters of oxygen per minute. So this is your total cost. This is how much your entire body uses. VO2 max is how much 1 kilogram of your body uses. So anyway, kind of the difference there. The VO2 max lets you compare your metabolism to other people. So anyway, it just kind of lets you compare yourself with others versus your resting metabolic rate. This is just your entire body. So if you're larger, if you weigh more, your resting metabolic rate is going to be higher, even though your VO2 max might be different. I don't know if that. Sorry, I've been doing a couple takes of this, and I think I'm getting more confused. Anyways, VO2 max, price per ounce, resting metabolic rate, total cost. Okay, as far as how you're gonna do that. So let's say you want to find out if you know your VO2 max. Let's say it's like, I don't know, let's say it's like 42 or something like that, something crazy. Okay, so if we want to know how long it's going to take us to burn off our Thanksgiving dinner this week, say we eat 7,000 calories. Not recommending that, just trying to be realistic here. Just kidding. Okay, so how we're going to do this, we're going to set up our math so that we get rid of units we don't want. So we want to know how long it's going to take us to burn off this entire meal. So we have calories up here, so we're going to use our 4.825 calories per liter of oxygen consumed. Gave that to you in question 1, so we're going to cross off calories. So now we have liters of oxygen. We don't want to know liters of oxygen. We want to get into units of time. So we're going to use this over here, our VO2 max, to cancel out our liters of oxygen. So that's going to give us, down here we're going to have 42 liters of oxygen per kilogram per minute. Yeah, that's a really big VO2 max. Okay. Sorry, my camera's not focusing. Okay, so we're going to cancel out our liters of oxygen. This gives us terms of kilograms per minute. Okay, we're almost there. We want to get this into terms of just minutes. So last thing we need to do to get rid of kilograms, we know how much I weigh. So let's say I weigh 100 kilograms. I don't know what's realistic there. Okay, cancel out kilograms. Now we're just in terms of minutes. So now what we can do is we can take our 7,000, we can divide it by that number, and that number, and then that should give us how long it would take us to burn this off. When you're doing your resting metabolic rate, there's a video that Brother Shaw has on there. Put a link to that in the announcement as well. For resting metabolic rate, when we're using our spirometers, it's going to measure the volume of oxygen you're consuming, except for it needs to be adjusted to standard temperature and pressure, just so it'll work with these values. There's reasons for it. Anyway, he'll kind of walk through that and show how to include that.